All right, so if you've ever written multi-threaded code in Java, I'm sure you've had that moment where you just want to pull your hair out. You've written the code, you've told the computer what to do, but it just seems to have a mind of its own. Well, today, we're going to figure out exactly why that happens. We're going to dive into the huge difference between trying to control threads versus learning how to influence them. And trust me, getting this concept down is absolutely essential for writing solid concurrent apps.
Okay, let's jump right in with a classic problem. Let's say you have two threads. One's job is to just print hi a bunch of times, and the other prints hello. The big question is, how do you force them to run in a nice, clean, predictable order? How can you make absolutely sure that one runs before the other every single time? I mean, it sounds like a no-brainer, right? But as you're about to see, in the world of threads, nothing is ever quite that simple.
So if you just write that basic code and hit the run button, this is what you get. A total mess. A jumble of highs and hellos all mixed up. And if you run it again, you'll get a different mess. This is because there's a puppet master behind the scenes called the thread scheduler, and it's juggling everything based on its own secret rules. So our challenge is to find a way to bring some order to this chaos.
So our first instinct, and it's a good one, is to ask, well, can I just tell the scheduler which thread I think is more important? And that leads us straight to our first attempt. Let's try using thread priority. The whole idea is to give one thread a higher rank, kind of hoping the scheduler will see that and decide to run it first.
So Java actually has a built-in system for this. It's a simple scale from 1 to 10. Min priority is down at 1, max priority is up at 10, and by default, any new thread you make just starts right in the middle, at 5, which is called norm priority. And you can check this with get priority, and more importantly for us, you can change it with set priority.
Let's actually put this to the test. To make our hello thread the VIP, we just write this one simple line of code. We're telling our second thread, T2, hey, you're the most important thing right now, by setting its priority to thread.max priority. This is basically us waving a flag at the scheduler and shouting, hey, pay attention to this one.
Okay, the stage is set, we've given our instruction, we've cranked the priority all the way up to the max. Logically, we should expect to see a perfect stream of hellos, and then, only after they're all done, we'd see the highs. But the real question is the scheduler actually going to listen to us?
And the answer is, nope. Look at that, it's still a complete jumble. Even with the highest possible priority, the scheduler is just mixing them up however it feels like. And this, right here, is a huge aha moment for so many developers. We gave what felt like a direct order, but the system just didn't care. This tells us something really fundamental about how Java threads work.
This is the key lesson, right here. Thread priority is not a command you issue. It's more like a polite suggestion. The thread scheduler is this super complex piece of software. It might be looking at other things, like maybe one thread is just waiting around, so it gives it a turn. So while setting priority can definitely influence the outcome, it gives you absolutely zero guarantees.
Okay, so plan A didn't work. We can't just tell the scheduler what to do. So what about plan B? What if, instead of trying to promote one thread, we force another one to just stop for a second? This brings us to our second attempt. Let's try making a thread take a little nap with a method called Thread.sleep.
The idea behind sleep is really straightforward. You call it from inside a thread, and you're basically telling it, hey, go sit on the bench for a few milliseconds. This pulls it out of the competition for CPU time, and that creates a perfect little window of opportunity for other threads to jump in and get some work done.
Using it is super easy. You call thread.sleep and just tell it how many milliseconds to wait. But, and this is a big one, there's a catch. This method can throw something called an interrupted exception. That means Java forces you, with a compiler error, to wrap your sleep call in a try-catch block. Why? Because it's possible that another thread could rudely wake this one up while it's sleeping, and your code needs to be ready for that.
Now let's check out the result of this new approach. What we'll do is right after our high thread prints, we tell it to sleep for just a tiny bit. This gives the hello thread a clear shot to run. And would you look at that? We get a beautiful, orderly, alternating sequence. It really looks like we found a much better way to get the behavior we want.
But here comes the final twist. Even with sleep, it's still not a 100% ironclad guarantee. It's totally possible for the scheduler to let the hello thread run, and then, for whatever reason, decide to give it another turn right away, so you could still see two hellos in a row. It's way less likely, but it can happen. And that just brings us right back to our main theme. We are influencing, not controlling.
So after trying these two different approaches, we end up at the exact same place. We get to the core lesson of this whole thing. When you're dealing with multithreading, you have to completely shift your mindset. You've got to stop thinking like a micromanager trying to control everything and start thinking about how to properly influence the system. So let's compare them side by side. Thread priority is just a hint, a little nudge, that the scheduler is completely free to ignore. Thread.sleeping, on the other hand, is like putting up a stop sign. The scheduler has to honor that pause. But notice that one is a suggestion and the other is just a temporary stop. Neither one is giving you direct, absolute control over the execution order.
And this, really, is the ultimate takeaway. You, the programmer, cannot command the thread scheduler. It's just not how it works. Your real job is to understand the tools you have, like priority and sleep, and use them cleverly to suggest and influence the scheduler's behavior so you can get the result you want as reliably as you can.
So, let's recap the big points you absolutely need to remember. First, thread priority is just a suggestion. Second, thread.sleep forces a pause, but it doesn't guarantee what runs next. Third, at the end of the day, the thread scheduler calls all the shots. And finally, your main goal is always to influence, not control. Get that straight, and you're on your way to mastering concurrency. This all leaves us with one massive, important question, doesn't it? If we can't truly guarantee the exact order of things with these basic tools, how in the world do people build reliable, complex applications where sequence and data safety are critical? Well, the answer to that lies in more advanced concurrency tools, things like locks and semaphores, which give us a much greater degree of, you guessed it, control. But that's a whole other story. Thanks for joining me.